everyone. Thank you for attending my presentation. I'm Nidhal from TU Dresden. I'm working as a researcher and PhD candidate in Technical University of Dresden. I will present today my paper titled From Static to Dynamic Information Container, which is developed under the supervision of a Professor Raimar, and which is also related to the research project IECO, which stands for Intelligent Empowerment of Construction Industry. Actually, IECO is one of the first flagship projects of the German Gaia X funding competition. The aim of this research project is to completely digitize the processes in the construction industry and thus increase their productivity up to 10%. As introduction to my research work and my paper, actually I want to talk about the collaboration in construction industry, but I will not go in detail because all of us know that in the construction industry, experts from different and various domains participate in a project. Also, different stakeholders constantly want to share and exchange heterogeneous information, and thus data silos are widespread in the construction industry that make collaboration and coordination efforts it's more difficult. So for this purpose, actually there are two approaches were developed a decade ago, and I think almost in the same time. The first approach is the multimodal approach, which is developed by Professor Raimar Scherer and TU Dresden and Mephisto project. And the other approach is Dutch coins, which is also developed in Netherlands. The combination of these two approaches were the basis for the development of information container for linked document delivery, which is standardized in 2020. Actually, this standard is providing a specification for the creation of the information container and also for the link creating using the main two ontologies, container ontology and linkset ontology. Also, the standard provides specification for versioning, but this versioning actually is limited just to the classes of the container and the document, and the document and the link set itself. So that's mean when we are creating information container, for example, the simplified one that I show here, which is contain just two documents, we will need to create, and we want to create a links between these two documents, for example, to link building elements with its related items in the construction schedule. So for a medium size of a building, it will be not less than 10,000 of links to be created, and it's mostly done manually currently, to be created and to create the link set file. So what happens if the building element is versioned? So we will need to create a new link set because at that time the container will become out of date. Actually, not the all container, just the link set, because as we said, we can version the container, we can version the document, we can version the link set itself, but the content of the link set will be out of date. So we will need to create a new link set and so on. Actually, this is error-prone, time and cost significantly taking time and cost efforts. So instead of recreating the link set every time a document is versioned, so we proposed an algorithm which consists of two steps. I will not go for it. For more detail, please return back to the paper itself. But actually, the aim of this development is to expand the information container workability and to have up-to-date information container. And for this to be achieved, actually, I did just one minor change to the specification. I know it's not applicable now, but I do believe that we will add significant value to the workability of the information container. The change I did is in the specification, it's stated that for each link element, it's allowed just for one document to be added. But I changed this restriction to be minimum one document, so that whenever a new version of a document is added to the container, based on the algorithm developed, it will be added to the link where we have this document is contributed in the link set. So actually, there is some limitations in this approach. The first limitation is the file name, because the checking of algorithm is dependent on the file name itself, and the most significant limitation that we have here, that the automatic update of the link element depends critically on the ID, element's ID. So it's very critical that the element ID is not changed. For example, if we have a document containing, for example, a wall, and this wall is deleted for some reason, by mistake, for example, and then after, when a new version of this document, they returned back, added this wall. It will be with another ID, of course, so it will not be considered in the versioning process of the algorithm. So this is actually a significant limitation in this approach. For approach verification, I create a small example for a container containing from just two documents, the building model and the construction schedule. I create links between the elements inside them using direct links. And as you see here on the left side, a copy of the link set file showing the link between the two documents for just one link, which is a wall. And when I versioned the building model, the building model version 2 is added directly to that link, and again when its version is added. And for more verification, I delete this wall and add a new version of the document, and it's not added to the same link because it doesn't contain the wall itself again. Actually, my current development, I'm working on a dynamic multimodal engine. It's contained 6 functionalities. The first 3 is based on the standardized information container, and the other 3 is based on my development to have a dynamic multimodal container. And for that, we developed in our institute a web service to implement these functions. Actually, it's developed specifically to be as a prototype for the use case of digitize the environmental process. As you see here, we have 2 different visualization. The end user is simply can choose 2 different documents and select on each element from each document and directly link them. And we have here a building model, and the other side we have a URL link to the environmental data, which shows the groundwater level for the same area where the building is. And this is our development in the institute currently. So for a conclusion, I do believe that our work addresses an actual weakness and the mentioned ICDD. And this research is aimed not only to have automatic update information container, but also to have up-to-date information container to support the planning process and asset management over the building life cycle. And also the dynamic ICDD aimed at facilitate an efficient collaboration among players in the construction industry projects and provide more valuable services for overarching interdisciplinary decision making. And for validation, actually currently I intend to validate this approach in 2 use cases. One of them is integrating of semantic temporal information in BIM using ontologies, which is yesterday presented my colleagues Albrecht. And the second use case is actually my task in ECO project, which is to digitize the environmental planning process as a smart advanced service. And we are welcoming for any other use cases. Yeah. That's all from my side.